All right, we're going to continue on with our wonderful quadratics unit here with a little recap from Algebra 1. So we have a graph of a quadratic. All right, so it's a parabola. It'll either look like this or it'll look like this. That was pretty terrible. Basically like a U or an N shape, right? Okay, so that's what our graph is going to look like wherever it might be on that XY coordinate grid. But something like that. All right, so there's a vertex. Where is the vertex? Our vertex is either at the bottom or at the top of the graph, right? So vertex. Awesome. Now there are a couple ways of finding that pending the form of the equation, but it is tied to the axis of symmetry. So I'm just going to go ahead and draw in the axis of symmetry while we're at it in red. So our axis of symmetry just cuts the graph right down the middle, right? It can be reflected over that. It's symmetrical, hence the name axis of symmetry. Cool. So axis of symmetry is found by doing x equals negative b over 2a. Now this guy right here also provides the x coordinate of our vertex, okay? And then our y coordinate can be found by plugging it back in. Plug x into the equation. All right, there we go. Let's see our x-intercepts. Well, our x-intercepts are where it crosses the x-axis. So say this one here had a graph that looked like this is my x and y axis. Okay, so this is my y, this is my x. My x-intercepts would be right here and here. Cool? All right. My y-intercepts is where it crosses the y-axis. So if I were to extend my y-axis, not like that, because then it looks like it never crosses, but yeah, eventually it'll cross. Wherever it hits, somewhere around here, would be my y-intercept. Or you might see it looking like, let's see here, let me get a different color. So say we've got this guy right here. Boom, we've got a couple x-intercepts. Here's my x-intercepts. And then we've got our y-intercept right over here. Y-intercept. Okay, so where it crosses, x-axis, and here it's where it crosses y-axis. Now, how do we figure these things out? How do we get our x-intercepts or our y-intercepts? Well, if you're given an equation, you could factor and solve, or maybe quadratic formula. Quadratic, formula. Very good. Where it crosses the y-axis. Well, where does that happen? It happens when x equals 0, so we can basically plug 0 in for x into our equation. Okay? Now, all these things we're going to be able to practice with here in just a sec, or maybe we'll put up a little problem here with all of our information. So let's see if I can maybe unzoom all of this. Hey, that works. So zoom out. Other word for unzoom. Okay, so let's test this out with a problem here. So okay, there's all of our exciting stuff. So let's go with the equation y equals x squared plus 6x plus 8. Okay, let's find out all this information. So first would be our vertex, which is in conjunction with our axis of symmetry. So if I take x equals negative b over 2a. Well, what are my a, b, and my c? Well, a quadratic is written in the form ax squared plus bx plus c. Now, that is standard form rather than vertex form. So all the numbers in front, our coefficients, are the letters a, b, and c. So b is 6 in this case, so it would be negative b. So negative 6 over 2, and then a is 1 in this case. All right. So all that gives me is negative 6 over 2, which is negative 3. So that is my axis of symmetry, and it's my x-coordinate of my vertex. So vertex, actually, why don't we do this? We'll put it all over here. Vertex, that is negative 3, comma, I don't know. Axis of symmetry is x equals negative 3. So I get like a 2 for 1. Then we've got our x intercepts and our y intercepts. Okay. So, how do I get my y-coordinate? We plug it into the equation, right? That's what it says right over here. That's what we jotted down. How do we get y? We plug it into the equation. So if I do that, I'm going to have negative 3 squared plus 6 times negative 3 plus 8. So I've got 9 minus 18 plus 8. And if I do this in my brain, I get negative 1. Very good. So 9 minus 18 is negative 9, plus 8 is negative 1. Cool. So that's taken care of. Now for my x-intercepts. So how do I get those? Well, I could factor and solve if it's factorable, or I could use quadratic formula. Let's go with factoring if it's possible. Well, what multiplies to 8 and adds to 6? Well, that would be 4 and 2. So if I set these each equal to 0, which is essentially setting the equation equal to 0, or setting y equal to 0, I would get 0. X equals negative 4, and x equals negative 2. And you'll see them written as like negative 4, comma 0, and negative 2, and negative 2, comma 0, as ordered pairs, since they're technically points. And then our y-intercept is found by just plugging 0 in for x. And if I do that, I'm going to have 0 squared plus 6 times 0 plus 8. So I'm really just left with 8. So 0 for x, comma 8 for y. All right, awesome. So those are all the pieces, parts of a quadratic function, at least for what we're going to deal with here in class. Our main thing will be obviously applying this information. You may have gotten into some of that with Algebra 1, but that's going to be our focus going forward as we've got all the nuts and bolts now of a quadratic function, what it is. We're going to talk about the importance of our x-intercepts, what they mean, what our y-intercepts mean, what our vertex means in another video. Okay, but we're going to go over the quadratic formula here real quick and then call it a day. All right, our quadratic formula. Everybody loves the quadratic formula. You may remember it. It's x equals negative b plus or minus, because there's two answers, b squared minus 4 times a times c, all over 2a. So if I had the equation, I'm going to go with 3x squared, say y equals 3x squared plus 4x minus 8. Okay. So, how do I solve this one here? Well, if I could factor it, I'd factor it. And I would use like rainbow method or guess and check. But there's this one's not going to factor. So we got to figure it out another way. Well, we can use our quadratic formula. Hence, writing it down. Okay. So this is my A, this is my B, and this is my C. When I plug that in, it's negative B, so negative 4. If that 4 was negative, it would change to positive, right? Plus or minus, and this is now x equals the square root of B squared minus 4 times A, so times 3, times C, which is negative 8. Okay. All over 2 times 3. Cool. Now, I am more than happy to have you guys plug this all into your calculator rather than simplifying and all that stuff. Simplifying the radicals, it's much more of like an algebra type of concept. Since we're going to be dealing with applications, we're going to be dealing with like the decimal answers. So we could basically just plug it all into our calculator all at once. So negative 4 plus, We're going to have to do this 2 times, all right? Now, if you are going to be dividing by 2 times 3, make sure you're using your parentheses properly. So I'm opening a set of parentheses, and then I'm going to work, all right? Alrighty, so when I plug all this into my calculator, it's going to look something like this. Since I can't show my calculator right now, I will kind of write out how I typed it in. I opened a set of parentheses, -4, then I did plus the square root of 4 squared minus 4 parentheses 3 parentheses -8, close them, then get out of the square root and put another closed parentheses, divided by, then you have to open a set of parentheses to do 2 times 3, close them, okay? If you just did how it looks in the denominator over here, it would divide by 2, then multiply everything by 3, and you're going to get a weird answer. So definitely try plugging this in. So when I did the addition one, I got x is approximately, oops, didn't mean to undo that. X is approximately, let me make it squiggly, 1.097. We'll do 3 decimal places. It's a 7 there. And then what you can do is you can just arrow up in your calculator if it has that capability. Some of the older ones do not. But you can arrow up and you can grab it and change this guy right here to subtraction. And then it will come out as -2.4305, so 1. And those would be my 2 x-intercepts. All right? So that's the basic gist of how to work with it in the quadratic formula. This is obviously just going about it with decimals rather than simplifying radicals and all that. Since we are using it for application, that's what we'll be doing in this class. When you get to Algebra 2, you will be simplifying the radicals rather than using the decimal equivalent. Okay? Awesome. America.